Good afternoon.
Good afternoon.
Okay, so your exam grade 1 is up, so you can check your grade on Blackboard. So here I give you like a roughly the class standard. So there are 1 people got perfect scored, and there are 10 got 35 above, and there are 41 got 30 above, and then there are 57 got 25 above. And there are 95 get 10 above, and there are 99 get 1 above.
So you're gonna use that to curve the grades?
Yeah, so so you won't see any curves on the score. So wherever you see, that will be your exam score. Now, since your final grade will determine by the 3 exam grade, so those score here are out of 40, right? So your final class score will be determined by your 3 exam score and also your lab component. So I will just give you like a rough standard for this exam. So I will say if you get 34 and above, then you will be in the A range. A range means it could be an A or it could be an A minus. And if you get 28 above, that will be in the B range. So that will include B minus B, B plus. And if you're in 20 above, that will be in the C range. And if you're in the 10 above, that will be the D range. Okay. And also I make announcement that for those who got a 0 on the exam 1, that means your exam shows that you are cheated, which it will be reported to the department and also the school.
Somebody cheated, you said?
Yes. And there is clear evidence on where is the source code is from. Okay, so I see people asking, isn't 28 over 40 or 70? Yeah, so it's not, so I don't do like a fraction grade. So it's not like you take the score over 40, that's your score. So again, if you got a 34 and above, then you were somewhere in the A range. And if you got a 28 and above, you were somewhere in the B range. Now, this does not imply your final scores, and this is just one exam score. And I see people asking, 99 people got a score. Now, this means 99 of the score got 1 above. All the score here, it means it's included here. So it just means that 99 people got at least 1 point. Okay. Okay, then we will move on now. Okay, so last class we talked about the parameter of function. So we know the parameter of a function are used as a variable by a function, right? So you can name the parameter wherever you want, since it's is used as the variable as function. Now, wherever the changes you made in the function, which is the change you made in the parameter, are temporary. Right, so this is what we normally used, right, call by value. Now it will be temporary unless it's a reference parameter. So it's a reference parameter if you have an ampersand, right, in between the type and then the variable name, which you call it by reference. If you call by reference, then whatever change you made to the parameter, it will not be temporary, it will be permanent. So whatever change you made in the function, it will affect the actual variable you give as the input. Okay, so now let's look at this example here. So you have the change function. So the change function appear here, right? So if you look at the main function, we have int a equal to 3. So we initialize variable a to be 3. Then we will print out a equals to, and then whatever the value a. Right, so we initialize a with 3, so we will print out a equals to 3. So that's what here will print out. And then we will change a to 7. So from here, we will expect it to print out a equals to 3. Now, after the change function, we will expect a to print a 7. So how should we write this change function?
Use reference.
Okay, so we know we need to use a reference parameter. So what will the title line of our function look like?
Void change. Then you have the first is an integer reference and then a regular int.
Okay, so we will pass in two parameter. So first parameter, we want to choose the actual value. So we need to call by reference. So it will be the reference parameter. So we have the ampersand, and then we can name it whatever we want. So we can name it X. And then we have a second input. So we have a second parameter. Now we can call it int and then y. Now the second value, we just call by value, right? The second parameter, since you don't need to change the value. Then in our body of the code, what do we do?
X equals y.
So we just change x equals to y, and then what?
Return.
Okay, then we can just have the return, and then we end here.
Would
So
you get
let's,
like a, would you get like a compiler error if you passed in like a integer literal and for the first argument?
if you're passing as the reference parameter,
Yeah, like if you pass in 8 for the reference parameter.
yes. So if you put ampersand for both x and y, you will get a compiler error, and we will see why here.
Okay.
So let's make the change function, and then we'll have int x with the reference parameter, and then
Isn't it void change? Sorry.
yes, it will be void, since we don't need to return anything. Okay, so here is our change function. So the x, the first variable, will pass in as the reference parameter, and then the second will be passing by the value. Okay, so if we run that, we will have a equals to 3, and then after we run the function, we change the a to 7, we'll have a equals to 7. Now let's just change the second variable. And then we pass in as the parameter as well.
What does int and x mean?
Okay, so this %, this notation here, the % here we put in, this means we will call this parameter by reference. So this will become a reference parameter. Right, so remember when we pass in parameter, there's 2 ways we pass in. One is we call by value, we pass in by value. So which means whatever changes you made to the parameter are temporary, which means whatever change you made in your function, it will stay there. Once you get out of the function, your change doesn't exist. Now, if you add this %, before the variable, right? So you put the % between the data type and then the variable name, then you are calling it by reference. And this means whatever change you make to it, it will affect the variable outside of the function. So if you make any changes to x, that's your first parameter, right? That's your a you pass in. So whatever change you make it to the x, it will affect the a, and that's what happened here. Right, that's what happened here. So if you look at it, we want to change a to 7, right? So we pass in a and we pass in 7. So we will change x to y. So we will change x as the y value, the second value, and whatever change we make to x, since it's passing by reference, it will change the a. So after we change it, our a will become 7. So we have a equal to 7 here. So that's what this %. Good. Now let's see what happens if we do a change on the y value here. So if we do that, and then we save it, and then we will compile it. If you see, we get a compiler error. And the error occurs here, right? Because for this function, our input need to be reference parameter. So a is a reference, right? So we will pass in the a, the variable a. So whatever change we made here, it will change the a. Now the second parameter, we define it as the reference parameter, but we pass in a 7. And this means if we want to make any changes to y, it should affect the changes outside of the function, but we pass in 7. You can't really change 7 because 7 is a number. So when we call something by reference parameter, you should only pass in the variable, not the actual value. You can't pass in any value like the integer or any string. Like you can't pass in the actual value. You need to pass in the variable if you have a reference parameter. Does that make sense?
So I have a question. Why in what case scenario would you need a reference parameter and not just pass in any like a regular parameter?
If you want the change to the function to be permanent.
So if I pass in x to change, will x change everywhere? Will it change globally?
Okay, so this means, so if you pass in, right, if you pass in the x, with the reference parameter, right? If you look at here, we have the n% with the x. This
Yeah.
means whatever change we make inside the function will also affect the value outside, since this is a reference parameter.
Oh, so it changes globally. Okay.
Yes.
All right.
But if you don't pass with x, then whatever change you make, it will only stays inside of your function. It won't change outside of it.
I see. Okay. Thank you.
And because of that, if you have a reference parameter, you can't just pass in the actual value. You need to pass in the variable. In case you want to change it, then whatever change you make to it, it will affect the variable that you pass in. Does that make sense? Okay, I see people asking, will putting an n% before the y be a compiler time or runtime error? No, it's just a compiler error. It doesn't compile. Because you didn't pass in the you didn't pass in the argument that match with the data type, because you need to pass in a reference instead of the actual value. Good.
Okay, thank you.
Okay. Now here, one way to get away with it, if you want to pass, if you also want to pass y in by a reference parameter, then what you could get away with it is create a variable b called 7. Then you can change a to b. Then this way you will also change a to 7. Now you will pass in b as your second reference parameter, but you are not changing. But in your function, you did not change the second value. So if we do that,
So you always need to attach it to a variable.
if you pass in by the reference,
Okay.
right? If you have reference parameter, then you can only pass in the variable, not the actual value. Okay, so now when we compile it, you won't get the compiler error. You are able to change it. But you also not changing the b value, since in your change function, you change nothing to the second value. Okay, so normally we're trying to, again, I think last class we also mentioned it. Normally we're trying to avoid reference parameter, because if you are just uncareful and then if you just change something in your function, you already make change in the actual data and you can't really undo it. So in general, you want to avoid reference parameter as much as possible, unless you really want to change the data for your function, then you do that. And if you have a function that have reference parameter, normally you will have the void type, right? Remember we say that each function, like a good function, should do just a single task. Right, so if you pass something in by the reference parameter, then you will expect it to change something to your data, and that will be the task you are doing. So normally, if you have a reference parameter, you will have a void type. Then the task of your function will be to change the data. Okay. Any questions here? Okay, if not, we will move on. So today's class will be focused on recursion. Now you probably don't know what's a recursion for now. Some of you might heard of it. Okay, so it's related to function. And we know that we can call a function pretty much anywhere, right? You can call a function from the main function. That's what we mainly doing the exercise with, where we call a function from the main function. Now it doesn't really need to be main function. You can also call a function from another function, right? Now you can also call a function from Excel. Now it might sound a little strange, right? You have a function calling Excel. In other words, you have a function that saying that to do your task, you need to do your task. You need to do its own task. Now it might sound strange now, but we will see how it works. So let's look at the following example. So let's say we want to create a function called factorial that will calculate the factorial for you. And we know the factorial will define as the following, or we have n factorial will equals to 1 times 2 times 3 up to n. Right, so if you look at now here, so we want to write a factorial function. Okay, and we know we can write it with a for loop. So you can multiply 1, 2, 3 up to n. Now let's do it without the for loop, right? We want to do it with the function. Okay, so let's just observe something, right? So we have n factorial. So let's look at 4 factorial. What does 4 factorial equals to?
4 times 3 times 2 times 1.
Okay, so you can do 4 times 3 times 4 times 3 times 2 times 1. And what does that give you?
24.
24. Now what other factorial you know? Like maybe 5 factorial. Now what does 5 factorial equals to?
5 times 4 factorial.
Okay, so 5 times 4 factorial, or you can have 5 times 4 times 3 times 2 times 1, which is the same as 5 times 4 factorial, and that will give you 120. Now what about 6 factorial?
Six all the way down to 1.
Is you can have 6 times 5 times 4 times 3 times 2 times 1. And that's pretty much give you 6 times 5 factorial. And that will give you 720. Now let me just give you some numbers. So the 7 factorial, right? If you just observe the pattern, we will get 7 times 6 factorial, which will give us 50, 40. Now, if you look at 80 factorial, that will just be 8 times 7 factorial, and that will be 40,320. Now, let me just give you one more. 9 factorial will be 9 times 8 factorial, which will give you 362,000 and then 880. Now, if I ask you what's 10 factorial, this should be easy to compute. What would the 10 factorial be?
10 times 9 factorial.
10 times 9 factorial. Since we already know what's 9 factorial, you can just add a 9. You can just add a 0 at the end. So we kind of find a pattern here. Right, so to find n factorial, how do we so how can we find n factorial? So if you look at the pattern here, right, what we did here, how do we find n factorial?
N times n minus 1 factorial.
So we will take n minus 1 factorial and we will multiply by n. Right, since here we have n factorial is equal to n minus 1 factorial times n. Now this formula is what we write in math. Right, so in C++, if we want to have a formula for n factorial, right, let's say we call it factorial of n. Then we know the factorial of n will equal to n minus 1 factorial, right, which we have factorial of n minus 1 times n. Now this is where the recursion comes in. Right, so to remember before we have so recursion is where you have a function calling itself. So if you look at it here, here you have to compute the function factorial of n, you need to compute factorial of n minus 1 and then times n. So do you see, like, to do the task, you were asking yourself, like, how do you do your own task?
So it's the same task, but it's a smaller subproblem.
Yes. So let's see what does C++ do to it. So we want to see what does C++ do. Okay, so let's say we want to find 4 factorial. Then what will it do? So to do the factorial of 4, the C++ will say, find 3 factorial for me, and then you will multiply by 4. Now, since you asked it to find 3 factorial, then your function will ask you to find 2 factorial for you. And then you will multiply by 3 to get 3 factorial. And to find 2 factorial, it will ask you to find 1 factorial and then multiply it by 2. And then to find 1 factorial, it will ask you to find 0 factorial for you. And then it will multiply by 1. Now, what's the problem here? Now, what we do here? Now, for the 0 factorial, if you just keep going, what we look for?
-1 factorial.
-1 factorial. Now, does -1 factorial means anything?
No.
No. Right, so we should stop it somewhere. Right, so keep looking down like the smaller factorial, it will work up to a certain point. So where do we want to stop? Okay,
At 1
CPO.
factorial.
Okay, so CPO say we have to stop at 0. So we could stop at 0 or we could stop at 1. 0 factorial is defined to be 1. But I will say here, it will make more sense if we just stop at 1. Right, so here, right, we want to stop here, which we will define 1 factorial equals to 1. So once you reach 1 factorial, you will just know it equals to 1. So you don't need to keep going down to find the smaller one, since 1 will be the smallest one. Okay, so for the recursion, how it works is we will keep looking for a simpler version of our task until we reached the simplest case, which there will be a stopping point where we don't want to keep going down anymore. And that will be the simplest case. And with C++, right? So for us, when we do recursion, we know we will stop at 1. But C++ won't know where to stop unless you tell it. So with C++, we must tell it. We must tell it where to stop. So our code will look like this. So we want to write our function. So we know we will return, we want to return an integer, right? So we will have int, the factorial function, and then we will pass in an int. Now we know to return the factorial function, we will return factorial of n minus 1 times n. Right, that's how we define the factorial function. But we need to stop when it reaches 1. So if n equals to 1, or if n is less than or equals to 1, we will return 1. Otherwise, we will return, so we will look at the easier version, n minus 1, and then multiply with the n. And that's how we get the n factorial. So this will be our function. Any question?
Is this kind of like mathematical induction?
Yes, but induction is you're starting at your base case, the very first case, and then you want to show it work up to the end. Now recursion is kind of backward of it,
Okay.
right? You're starting from your end, and then you need to tell it where it stopped. So where you will stop looking for the easier one. So you will start from your you will start at n, and you will keep breaking down to the smallest. You will keep looking for the simpler task or the smaller task until you can go down, and then it will kind of come back to it.
Okay.
Okay, so let's put the code in. So this is the base case, right? So when n is less than or equals to 1, we will just return the 1. So that's the case we will manually stop. Otherwise, we will return, right? So now here we will, it will be a function that calling itself. We have a factorial, right? It's calling itself, n minus 1, and then multiply with n. Now I see people asking before, how does it loop? So if you start with the n factorial, to do n factorial, if your n is greater than 1, then you will return the factor of n minus 1 times n. So you will look for the easier version. Then you will compute the factorial of n minus 1 and then multiply with the n. Now to do for the smaller task, so it's like you will pause here, you will go do a smaller task, and then pause to do a smaller task until you reach 1, and you will get an answer, pop up to the previous step, and then keep popping up until you are on your where you call it. Now in the main function, let's just see out factorial of, let's do a 8 factorial. And let's just check. Let's just do a 10 factorial. So we just check the two values since we have the we have 8 factorial and 10 factorial calculated here. Okay, so here is our code, pretty much the same as here. And then the main function, we bring out 8 factorial and 10 factorial. And then we will run it. So it gives us 40,320. So that's the 8 factorial. And then we have 36 to 8,800. Right, so that's the 10 factorial. Any questions here? Okay, so the way induction works, so let's look at the rule here. Okay, so first when you trying to use recursion, you must ask yourself how to do a simpler task. Like what's the easier version of your task? And also you also need to detect the base cases. But you need to give an ending point. But where were you not able to go down anymore, right? So you need to detect the base case where you can't get any simpler. You can't break it down anymore. So for the factorial question, we want to stop at 1 factorial. Once we reach 1, you don't want to keep going down anymore. Okay. Now, so this too is a rule. Now, number 3 is advice, is not a rule. It says that don't ask how C++ do its job. So for now, I mean, eventually you need to know exactly what it does. But for now, just trust that C++ will do its job. It will do a simpler version of the task correctly. Now, it's important that when we do recursion, it will call its own function to do a simpler task, because you don't want it to, you can ask it to do like a harder task if you don't know how to do it. But you can make it simpler and say, oh, here's the simpler task, do that instead. Okay, so you can trust the C++ will be able to do the simpler task or a simpler version of the task correctly for you. Now, instead of ask how C++ how to do its job, ask yourself, what's the simpler job that would does the most work for you? Right, so for example, in the factorial question, for the n+1 factorial, the instead of the, so if you look at here, right, so let's say to compute 4 factorial, well, you can look at 3 factorial. You can find 3 factorial. You can also find 2 factorial. You can also want 1 factorial. But when we talk about simpler task, we are asking what's the simpler task that will do most work for you. So it will be like, it kind of just like one step before that. So it will be the 3 factorial. Like 3 factorial will do more job than just the 2 factorial. So here, right, for the advice 3, so you say, ask yourself, what's the simpler job that will do most of the work for you? And then the 5 is like when you code your recursion, or when you code your function, you should start your code by detecting the base case. So pretty much you will start with tell your function where to stop. Okay, so now let's look at this example here. If we want to print a triangle. Now we did this question with the for loop. Now let's see how can we do it with the recursion. So if you look at the main function, we have triangle of 4. So if we run the triangle 4 function, it will print us this triangle. So if you look at this triangle, right, we know this is like a 4x4 triangle. Now the first thing we will ask is, what's the simpler task? So this is triangle 4. What's the simpler task?
Triangle 3.
Triangle 3. Now what does triangle 3 look like?
The first 3 lines.
The first 3 lines, or the first 3 row. Right, so your easier task, right? So first you ask yourself, what's the simpler task? Now for this, it will be the triangle 3. Let me do it here. It will be triangle 3. Now for triangle 3, it will look for the triangle 2, and then triangle 1, and then what? Triangle 0. What does the triangle 0 do? Nothing. Right, so we need to, so the 3 here, it will go down to 2, 1, and then for triangle 0, it will do nothing. So we want to stop here. Right, so this means we want to stop here. And since we want to stop here, this will become our base case. Now, if you look at our triangle, right, so what's our title line gonna be for this triangle function? Okay, so it will be void. Okay, so I see people say int. If you have int triangle, that means it will return an integer to your function. But if we return an integer here, it does nothing. You are not printing it, right? So it will be void. So normally, if the function has the reference parameter, or if the function, it will just print something on the screen, you will have the void type. So we have void, and then we have the function name triangle, and then we will pass in an integer x. Now we know we will stop at 0. So if x equals to 0, or if x is less than 0, you know what, let's just have 0. I think the base case is when x equal to 0. Now when x equal to 0, what do we do?
Return.
Return. We'll just stop there. If you look at here, right, it do nothing. So if you just return, it do nothing. Now besides that, what do we do? Now to do triangle, what do we do? So do we see that to do triangle 4, if we want to print triangle 4, what are we doing? We will ask it to do triangle 3, then what? Right, this whole thing is the triangle 4. Right, this whole thing is triangle 4. But triangle 4 can be break down into triangle 3. You ask it for the smaller task, and then what? If you just have triangle 3, it won't give you triangle 4 because this is the easier task.
Then it goes to triangle 2.
Yeah, to form triangle 3, you need to go. You need to form the triangle 2. But I'm saying that to form triangle 4, to form this triangle here, we will ask it to do a triangle 3, and then what? Okay, I see people say, and then we need to have 4 stars. So also we need the last row.
So in general, it's going to be X stars at the bottom.
Yes. So if we see, do we see that to do the triangle 4, we will have a triangle 3 plus last row. And last row will be 4 star. So in general, if we want, so this means if we want to have triangle n can be break down as the triangle n minus 1 plus the last row, and last row will consist with n stars. So here when we have the triangle x, so for triangle x we will look at the simpler test, which we will print a triangle x minus 1. So you will print the smaller triangle, and then you need the last row. So you will have, you can have just the for loop. C equals to 1, and then C is less than or equals to x, C plus plus, and then we will C out a star. And then after the for loop, you will end the line. And then you will have return. And then you will finish your code here. Good. Any questions here? Okay, so because of the time, we will just I won't put this into the compiler. You can do it on your own. And next class we will pick up from here. We will do more exercise on recursion. Okay, have a nice day.
Thank you, Professor.
Bye, thank you.
Thank you,
Bye,
Professor.
Professor.